In the previous video, we had discussed about the intermolecular force of attraction and thermal energy of solids, liquids, and gases and how they are different from each other. In this video, we are going to be talking about gaseous state. We exist in a sea of gases. The atmosphere consists of various gases like nitrogen, carbon dioxide, oxygen, all of these which are required for, us in general. And this atmosphere is being held down by the Earth's gravitational force. So gases are actually considered as one of the simplest states of matter. And there are the substances which exist as gas in normal temperature, and we're talking about elements at normal temperature and pressure are these 11 elements. So there are just 11 elements that exist as gases at room temperature and pressure. So they're hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, and radon. So the substances which are called gases are basically the ones which can exist in this state at room temperature and pressure. Now, obviously, we need to learn about the various characteristics of gases. Okay, so compressibility. First of all, look at the intermolecular arrangement. There are a lot of spaces, so gases are compressible. Next is pressure. Pressure is exerted by the gas equally in all directions. So the pressure is due to the movement of the particles of the gas. Next, density. Density is basically the number of particles per unit volume. So obviously gases have the least amount of density compared to liquids and solids. Volume and shape. Due to the particles being so far apart and they having less amount of intermolecular force of attraction, they do not have a proper volume and shape. And a simple way of understanding the whole volume thing is the fact that, see, in a beaker, let's assume this is a beaker and we have some amount of liquid. No matter what, the volume of the liquid will stay the same. So if we measure it using a measuring cylinder or a burette, the volume of the liquid is going to stay the same. But suppose we have a gas. Let's assume we have some amount of a gas, right? And we've placed it in this box. The gas will occupy the entire area of the box. Entire volume of the box. Now, suppose we make the room or the box bigger. Then the gas will occupy the entire volume of this box as well. So that is why we say that gas does not have a specific volume and a shape. The next is diffusion. Obviously gas mix evenly and they basically do that without any external force or mechanical aid. Liquefaction. Now liquefaction is basically they can be liquefied by what? We learned about this in the previous video, by obviously reducing the temperature and providing it with a lot of pressure. The next one is the homogeneous nature. So, I'm sorry, this is supposed to be homogeneous nature. Gases are a homogeneous mixture. So, they will mix evenly in all directions. In the room that you're sitting and watching this video right now, that will have the amount of gases which are present is going to be evenly distributed in all the areas. So you can't just say, okay, this particular area of the room is going to have a lot of carbon dioxide or this particular area is having a lot of oxygen. So they're generally homogeneous in nature. So gases are considered simple because the force of interaction or the attraction between the molecules is quite negligible. And the behavior of these gases is governed by something called as the gas laws. So gas laws are very easy if you do it properly. If you understand the concept behind each law, you'll be able to do it flawlessly. Honestly, when I was in grade 11, I actually found it extremely difficult and I was never able to learn this particular concept for God knows what reason properly. So, but then when I was in college, one of my professors or lecturers, I don't remember who, one of my teachers basically gave me an easier way of understanding and or maybe I just understood it at that point. Anyways, gas laws consider 4 units and we'll be discussing that again for each gas law. Okay, we'll be talking about pressure, we'll be talking about temperature, we'll be talking about the amount of gas which is present, and so and temperature, pressure, amount of gas, and the number of moles, or volume and the number of moles. So what we'll do is, in each gas law we'll have two of the quantities as a constant, while two will be the variable. So that gas law will be a relation between two of the variables, while the other two are kept constant. And from that we'll be drawing some generalizations, and these generalizations actually help us understand the various properties or the various variations in terms of temperature, pressure, volume, and number of moles of gases. So in the next video we will be beginning with the gas laws, and the first one will be the Boyle's law. So to conclude, gases have the least amount of intermolecular force and highest thermal energy. They're compressible, they exert pressure in all directions, they have a low density compared to liquids and solids. They don't have a particular no specific volume or shape. They can undergo diffusion or mixing in all directions, and so they are easily without any mechanical aid. They undergo liquefaction while there is a decrease in temperature, as well as they get compressed. They are homogeneous in nature because they basically form a homogeneous mixture. Anything is considered a gas when they are in the gaseous state at room temperature as well as pressure. There are just 11 elements in the periodic table which exist as gas in room temperature and pressure. So hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, and radon are gases. Gas laws are the generalizations drawn between four different properties of gases, that is pressure, volume, temperature, and number of moles, and we'll be learning about Boyle's law in the next video.